Hello, my dear students. Welcome to Excellence Academy, Excellence PU College. Myself, Abhinam, mathematics lecturer and also the founder. I'll be doing a maths class today of class 10th, chapter 8, Introduction to Trigonometry. Okay, we shall see what are trigonometric functions, the basic definitions of trigonometry. There are 6 trigonometric functions, and we'll see the discuss trigonometric identities and work out the problems based on the trigonometric identities. Okay, the exercise 8.3 of NCERT textbook of class 10th. Okay, so we'll see what are the different definitions of trigonometric functions. They've got 6 trigonometric functions. We know sine, cos, tan, cot, sec and cosec. There are 6 trigonometric functions. Chapter 8, Introduction to Trigonometry, I am discussing now. Okay, it's a very important chapter. Sin theta definition, the basic definition of trigonometric function. Sin theta is defined as opposite side by hypotenuse. Cos theta is defined as adjacent side by hypotenuse. Tan theta is defined as opposite side divided by adjacent side. Okay, sine is opposite side divided by hypotenuse. You know, hypotenuse is the longest side of a right angle triangle. Cos theta is defined as adjacent side divided by hypotenuse. Tan theta is opposite side divided by adjacent side. The basic definitions of sine, cos and tan. And these are reciprocal functions. Cosec is reciprocal of sine theta. Cosec theta is 1 by sine theta. Secant theta is 1 by cos theta. Cot theta is 1 by tan theta. These are reciprocal functions. If you take a triangle and we can define these trigonometry functions in terms of the size of a triangle. Trigonometry mainly deals with right angle triangle. Okay, so right angle triangle is must. If it is not a right angle triangle, suppose an acute angle triangle is given to you, we can draw one perpendicular and construct a right angle triangle there. Okay, so now we'll define, take a right angle triangle here and mark this angle as theta here. This angle is theta. Okay, triangle ABC. This is triangle ABC. This angle is right angle at B. This triangle is right angle at B. Angle theta is here. For angle theta, the side opposite is called as opposite side. And the side opposite to 90 degree is called as hypotenuse. The side which is opposite to 90 degree is called as hypotenuse. This is hypotenuse. You must know which is the hypotenuse. Hypotenuse is the longest side of a right angle triangle. It is a side which is opposite to 90 degree. The side opposite to 90 degree is called as hypotenuse. The side which is touching the angle theta is called as adjacent side. So here BC is the adjacent side. BC is the adjacent side. And the side which is opposite to angle theta is called as opposite side. AB is the side which is opposite to angle theta. So AB is called as the opposite side. AB is called the opposite side. So, referring to this triangle, we can define sin theta, opposite side by hypotenuse. Which is the opposite side here? In this triangle, opposite side is AB, hypotenuse is AC. So, AB by AC. Sin theta is AB divided by AC. Cos theta is adjacent side by hypotenuse, BC by AC. This is BC divided by AC. Correct? And tan theta is opposite side by adjacent side, AB by BC. AB divided by BC. It depends upon the angle theta. So this is angle theta. So this is opposite side, this is adjacent side. Sin theta is opposite by hypotenuse, AB by AC. Cos theta, adjacent side by hypotenuse, BC AC. Tan theta is opposite by adjacent. Suppose you take a triangle like this, same type of triangle, okay. This is right angle at B only. I'll interchange the angle theta. If this is theta, this is 90 minus theta. That also you know. Now I'll take this angle as theta. If this is angle theta, we know that the side which is opposite to 90 degrees is always hypotenuse. So hypotenuse is fixed. So angle B is 90 degree. The opposite side to angle B is hypotenuse. So AC is the hypotenuse. And AB is adjacent side, BC is the opposite side. Side opposite to angle theta is called as opposite side. Angle theta is marked here, no? Here it was angle theta as BCA. Now angle theta is CAB, correct? So the side which is opposite to angle theta is called as the opposite side. This is opposite side. Opposite side. And this is adjacent side. See the difference between these two. For this figure, I have written this. Okay. For this figure, if you want, just interchange. The opposite side and adjacent sides are interchanged. For this figure, if you want, sine theta is equal to opposite side by hypotenuse. BC by AC it becomes. Sine theta is BC by AC. Cos theta is adjacent side by hypotenuse. Adjacent side is AB. Hypotenuse is AC. AB by AC it becomes. And tan theta is opposite side divided by adjacent side. BC by AB it is. BC divided by AB. Okay. All these things you must know. Tan theta is opposite by adjacent. BC by AB. Correct? So, and cosec is reciprocal of sine, sec is the reciprocal of cos, and cot is reciprocal of tan. Also, I'll add one page and give you information connecting the trigonometry function tan and cot in terms of sine and cos. It's very useful sometimes. Tan theta is sine theta by cos theta. You must know this. Please make a note. Tan theta is defined as sine theta divided by cos theta. Theta refers to an angle here, remember. And cot theta is the reciprocal of tan theta, which could be expressed in terms of cos and sine as cos theta divided by sine theta. Cot theta is cos theta divided by sine theta. Tan is sine by cos. And there are trigonometric identities, they are also called as Pythagorean identities, or they are also called as square relationships in trigonometry. The square relationships in trigonometry are sine square theta plus cos square theta equal to 1 plus tan square theta equal to secant square theta, and 1 plus cot square theta equal to cosecant square theta. Three important identities we got. The trigonometric identities. The trigonometric identities are trigonometric identities. Trigonometric identities are sine square a plus cos square a equal to 1. Identities. Three important identities are. The first one is sine square theta plus cos square theta is equal to 1. Sine square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to secant square theta. 1 plus tan square theta is equal to secant square theta, and we have 1 plus cot square theta is equal to cosecant square theta. Sin square theta plus cos square theta equal to 1. 1 plus tan square theta equal to secant square theta. 1 plus cot square theta equal to cosecant square theta. These are called the fundamental trigonometric identities, also called as Pythagorean identities in trigonometry, because this can be proved using the Pythagoras theorem for a right angle triangle, and they're also called as square relationships in trigonometry. Okay, we can prove all these things one by one. I'll give the proof of this. Sin square theta plus cos square theta equal to 1. Look at the angles. Angles are same. If angles are same, then sin square plus cos square is 1. Angles are same. See, 1 plus tan square theta equal to secant square theta. Left hand side and right hand side, the angles are same. So I'll prove this one by one now. Okay. The proof of sin square a plus cos square a equal to 1. I'll prove sin square a plus cos square equal to 1. Take a right angle triangle. This angle is A equal. Okay, this is ABC. ABC is a triangle. Right angle at B. This angle is A. Of course, no need to mark. It's understood that that angle is A itself. Okay, this angle is A. Okay, referring to this angle, I'm going to prove. In triangle ABC, we have using the Pythagoras theorem, in triangle ABC, Using the Pythagoras theorem, the right angle triangle condition also we can call square on the hypotenuse equal to sum of the square on the other two sides. AC square is equal to AB square plus BC square. Square on the hypotenuse is equal to sum of the square on other two sides. AB square plus BC square. Okay. So to prove sin square A plus cos square A equal to 1, what we shall do is we'll divide this entire equation by AC square. Divide throughout by AC square. Divide throughout by AC square. Divide throughout by AC square. What we get? This is AC square divided by AC square is equal to AB square divided by AC square plus BC square divided by AC square. AC square by AC square, that is 1. Numerator is same as denominator, so ratio becomes 1. AB by AC the whole square I can write. AB square by AC square is AB by AC the whole square. And BC by AC the whole square I can write. BC by AC the whole square. This symbol is implies, okay? Or you can write that is 1 is equal to AB by AC. AB by AC is what? Referring to this angle A. AB is the adjacent side. AB is the adjacent side. Correct? And BC is the opposite side for angle A. BC is the opposite side. AC is the hypotenuse, the side which is opposite to 90 degree. Correct? This is the longest side of a right angle triangle. So AB by AC. AB is adjacent side, AC is hypotenuse. Adjacent by hypotenuse is cos function. So this is cos A. Correct? Cos A, the whole square I can write. BC by AC. BC happens to be the opposite side. AC is the hypotenuse. Opposite side by hypotenuse is sine function referring to angle A. So it is sine A. So sine A the whole square plus cos A the whole square. Cos A the whole square is nothing but cos square A. Sine A the whole square is nothing but sine square A. So what we get is 1 is equal to cos square A plus sine square A. 1 is equal to cos square A plus sine square A. Hence we proved this, the Pythagorean identity. It's very important. Cos square A plus sine square A is equal to 1. Or else you can rearrange and write cos square A is 1 minus sine square A. Sine square A is 1 minus cos square A. You can rearrange and write. If you take the same right angle triangle and consider the same condition of the Pythagoras theorem, okay, you divide the entire equation by AB square. Here what we did is we divide the entire equation by AC square. Again you consider the same equation, AC square equal to AB square plus BC square. Okay, we divide throughout by AB square. I'll write here itself. Again you consider the same equation. AC square is equal to AB square plus BC square. What I'm going to do is I'll divide the entire equation by AB square. AC square divided by AB square is equal to AB square divided by AB square plus BC square divided by AB square. This is AC by AB the whole square. Correct? AC by AB the whole square. Here numerator is same as denominator, so ratio becomes 1. 1 plus BC by AB the whole square. This is BC by AB the whole square. AC by AB. AC is the hypotenuse. Correct? AC is hypotenuse. AB is the adjacent side. Hypotenuse by adjacent is secant function. Adjacent by hypotenuse is cos function. Correct? Hypotenuse by adjacent is reciprocal of cos function, which is secant function. This is the definition of secant A. So secant A the whole square. Secant A the whole square is equal to 1 plus BC by AB. BC is the opposite side and AB is the adjacent side. Opposite side by adjacent side is tan function. So referring to angle A. So it is a tan A. This is tan A the whole square. So what I am going to get is secant square A is equal to 1 plus tan square A. Secant square A is equal to 1 plus tan square A. Secant square A is equal to 1 plus tan square A. Same equation you will consider again and you divide the entire equation by BC square. Again, write the same equation. AC square is equal to AB square plus BC square. You divide the entire equation by BC square. First time we divide the entire equation by AC square. Here we divide the entire equation by AB square. Now I am dividing the entire equation by BC square. Divide throughout by BC square. Divide throughout by BC square. Divide throughout by BC square. If you divide by BC square, what do you get? This is AC square divided by BC square is equal to AB square divided by BC square plus BC square divided by BC square. This is AB by BC the whole square. AB by BC the whole square. This is, sorry, AC by BC. AC by BC the whole square, correct? AC by BC the whole square. AC by BC the whole square. This is AB by BC the whole square. Numerator is same as denominator, so ratio becomes 1. AC by BC. AC is hypotenuse, BC is opposite side. Hypotenuse by opposite side is the reciprocal of sine function, which is cosec function. So cosecant square I am getting. This is cosecant square A. AB by BC. AB is adjacent side, BC is opposite side. Adjacent side by opposite side is what? AB by BC. Adjacent by opposite is the reciprocal of tan, this is cot function. Cot square A. This is cot square A. Cot square A plus 1. So 1 plus cot square A is equal to cosecant square A. So this is the relationship we have. 1 plus cot square A is equal to cosecant square A. 1 plus cot square A equal to cosecant square. Please learn these three identities, quite important. Please make a note of this. Proof is also shown here. Okay. Proof is shown here. This angle is referred here. Angle A. 1 plus tan square A equal to secant square A. 1 plus cot square A equal to cosecant square A. We'll take the problems based on this now. Express the trigonometric ratios sin A, secant A and tan A in terms of cot A. So we should express sin A in terms of cot A, secant A in terms of cot A, tan A in terms of cot A. So first one I'll begin with sin A. Sin A in terms of cot I should write. To express sine in terms of cot, we start with the identity 1 plus cot square A equal to cosecant square A. Correct? We have the identity 1 plus cot square A is equal to cosecant square A. 1 plus cot square A is equal to cosecant square A. And we know reciprocal of cosec is sine. Sine and cosec are reciprocals. So cosecant square A, I'll write 1 by sine square A. Okay? So from this symbol is implies, okay? 1 plus cot square A, 1 plus cot square A is equal to 1 by sine square A, this is. Or take reciprocals on both sides. Taking 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 reciprocals on both sides. 1 by sine square A, reciprocal will be sine square A. Sine square A is equal to 1 by 1 plus cot square A. Reciprocal of 1 by sine square A becomes sine square A is equal to 1 by 1 plus cot square A. Correct? So from this, we'll take the positive square root. Assume that A lies in first quadrant, that is acute angle. We assume A to be an acute angle always at 10th standard level. Okay, we don't take obtuse angle whenever we discuss trigonometry function at 10th standard level. We take A as an acute angle. So I'll take the positive square root. Root of 1 by 1 plus cot square A. Sine A is square root of 1 by 1 plus cot square A. Okay. So first one we got expressing sine A in terms of cot A. We want to express secant A in terms of cot A. So for that we can go for the identity. Secant A is 1 by cos A. Correct? Or else we can go for identity sine square A plus cos square A equal to 1. From there can we get sine square A plus cos square A is 1. Correct? Sine is, we got like this. No, we'll go for 1 plus tan square equal to secant square. From there we can get 1 plus tan square A is equal to secant square. We'll use that identity. 1 plus tan square A is equal to secant square A. Secant A you have to find out in terms of cot, correct? So secant A is what? Taking the square roots here, taking the positive square root once again. Secant A is root of 1 plus tan square A. So this is equal to square root of 1 plus tan square A is 1 by cot square A. Secant A is square root of 1 plus 1 by cot square A. So expressing secant A in terms of cot A. Second one is also done. We got sine A in terms of cot A, secant A in terms of cot A. Lastly, we got to find tan A in terms of cot A. Tan is 1 by cot, right? Tan is 1 by cot. That is directly we can write as a reciprocal relationship. Tan A is equal to 1 by cot A. 1 by cot A. Hence, we are done. Please make a note of this. Expressing sine A in terms of cot A, secant A in terms of cot A, tan A in terms of cot A. Sine A we got 1 by root of 1 plus cot square A. Correct? Of course, root 1 is 1. We can also write like this. Because root 1 is 1, no? We can write this as 1 by root of 1 plus cot square A. Because square root of 1 is 1 itself. Correct? Secant A is root of 1 plus 1 by cot square A. Tan A is 1 by cot A. That is what we got. Solution is also displayed here. Okay. Move on to the next one. Question number 2. Write all other trigonometric ratios of angle A in terms of secant A. So leaving secant remaining 5, you should express in terms of secant A. Start from cos A. Cos A is reciprocal of secant A, correct? The first one, I'll write cos A. Cos A is equal to 1 by secant A. Correct? Cos is reciprocal of sec, or sec is reciprocal of cos. Next, I'll express sine in terms of secant A. For that, we go for the identity sine square A plus cos square A equal to 1. We have the identity sine square A plus cos square A equal to 1. We have sine square A plus cos square A is equal to 1. Sine square A plus cos square A is equal to 1. You want to find sine A in terms of secant A. Correct? So from this, what you can write is sine square A is equal to 1 minus cos square A. Or from this, sine A is equal to taking the positive square root of 1 minus cos square A. Or cos A is what? Reciprocal of sec. So 1 minus 1 by secant square A. Sine is root of 1 minus 1 by secant square A. Cos square A is 1 by secant square A. Correct? So sine A is expressed in terms of secant A. Sine A is root of 1 minus 1 by secant square. If you want, you can take simplified further. We can write, take LCM inside the root and simplify it further. One more step we can write. This is, if you want, you can write this as root of secant square A minus 1 divided by secant square A. You can write like this. And root of secant square is actually mod of secant. All those things you don't know. Assuming that it is positive, we can write like this. Root of secant square A minus 1. Root of secant square A minus 1 divided by secant A. Square root of secant square A secant A, because we assume that A lies in the in the first quadrant. I mean, A is an acute angle, so secant A is positive. If secant A is positive, root of secant square A is secant A. So sin A we got in terms of sec. Next we'll go for tan. Tan is, if you want to express tan in terms of secant, we know the identity 1 plus tan square A equal to secant square A. 1 plus tan square A is equal to secant square A. From this, tan square A is equal to secant square A minus 1. Tan square A is equal to secant square A minus 1, or we get tan A is equal to, taking the positive square root, we get root of secant square A minus 1. Next, if you want to express cot A in terms of secant A, cot is 1 by tan. Cot A is 1 by tan A. Cot A is 1 by tan A, which is 1 by tan A is root of secant square A minus 1. Cot A we got. Cot A, sin, cos, tan over cot over cosec. Cosec is 1 by sin. Cosec A is 1 by sin A. Cosec A is 1 by sin A. Sin A is here. Cosec is reciprocal of this. So secant A by root of secant square A minus 1. Secant A by root of secant square A minus 1. Reciprocal of sin is cosec. So I wrote the reciprocal of this. So please make a note of expressing in terms of secant A the remaining 5 trigonometric functions. Make a note of this. Move on to the next one. Solution is also shown here. Okay, the simplification part is not done here actually. I have done the simplification part of this. We got some multiple choice questions here. Question number 3. 9 times secant square A minus 9 times tan square A. Of course, we can take 9 common here. Correct? Given expression is equal to 9 you can take common. If you take 9 common here, what remains is secant square A minus tan square A. Correct? Secant square A minus tan square A. We know secant square A minus tan square A is 1. So this is 9 into 1 is equal to 9. Because we know the identity 1 plus tan square A equal to secant square A. 1 plus tan square A is equal to secant square A. So from this we have 1 is equal to secant square A minus tan square A. Secant square A minus tan square A is 1. 9 into 1 is 9. Answer is option B. Learn this, okay? Identity based on that. Move on to the next one. Question number 4 we have. Solution is also shown here. Move on to the next one. Question number 4 we have 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. What we'll do is we'll express tan as sin by cos. Sec is 1 by cos. Cot is cos by sin. Cosec is 1 by sin. Go on, simplify this. So what is the given expression becomes? The given expression becomes 1 plus tan theta is sin theta divided by cos theta. Sin theta by cos theta. Secant is 1 by cos theta. 1 plus cot theta is cos theta divided by sin theta. Cosec is 1 by sin theta. Simplify this. The first bracket you take LCM, cos theta. So numerator becomes what? Cos theta plus sin theta plus 1. Correct? Take LCM as cos theta for denominator. Common denominator is cos theta. 1 into cos theta gives cos theta. That cos theta into 1 is cos theta. Cos theta to multiply by 1 to get this. That 1 into sin theta is sin theta. Cos theta to multiply by 1 to get this. That 1 into 1 is 1. Same way, take common denominator here. Common denominator is sin theta. Correct? This is 1 by 1. 1 into sin theta. This is sin theta plus cos theta minus 1. Here, sin theta plus cos theta and cos theta plus sin theta are one and the same. Correct? This is sin theta plus cos theta. Correct? Plus 1. Sin theta plus cos theta plus 1 into sin theta plus cos theta minus 1. Sin theta plus cos theta minus 1 divided by, this is sin theta into cos theta. This takes the form a plus b into a minus b. We know a plus b into a minus b is a square minus b square using this identity. A plus b into a minus b is equal to a square minus b square. Correct? Sin theta plus cos theta plus 1 into sin theta plus cos theta minus 1, which is a square minus b square. Sin theta plus cos theta the whole square minus 1 divided by sin theta into cos theta. A plus b into a minus b. This is a. Sin theta plus cos theta is a. 1 is b. A plus b into a minus b. A square minus b square. Expand this. Sin theta plus cos theta the whole square is what? Sin square theta plus cos square theta plus 2 sin theta cos theta. Expanding this. A plus b whole square formula. A plus b whole square is a square plus b square plus 2ab divided by sin theta into cos theta. Correct? Here sin square theta plus cos square theta is 1. This is 1. Sin square plus cos square is 1. Plus 1 minus 1 will add up to 0. Correct? So plus 1 minus 1 will add up to 0. What remains is 2 sin theta cos theta. 2 sin theta cos theta divided by sin theta cos theta. Sin theta cos theta is going to cancel. What remains is 2. So answer is 2. Option C is the answer. Please make a note of this. We use a plus b into a minus b. A square minus b square. The difference of two squares. And also we use a plus b whole square formula. A square plus b square plus 2ab. Sin square theta plus cos square theta is 1. 1 minus 1, 0. 2 sin theta cos theta remains the numerator. Denominator is sin theta cos theta. Sin theta cos theta cancels. 2 into 1. 2 is the answer. On to the next one. Solution is also shown here. Option C is the answer. Next one. Question number 5 we have. Secant A plus tan A into 1 minus sin A is equal to how much? Take the given expression. Secant A plus tan A. Secant A plus tan A. Secant A is 1 by cos A. Secant is reciprocal of cos. G stands for given expression. Secant A is 1 by cos A. Tan A is sin A by cos A. Tan A is sin A divided by cos A into 1 minus sin A is equal to 1 plus sin A divided by cos A, taking common denominator, into 1 minus sin A. Right, secant as 1 by cos, tan as sin by cos, take common denominator cos A. Okay, so common denominator is cos A, numerator is 1 plus sin A. Now I can multiply numerator to numerator. This is in the form of a plus b into a minus b. We know a plus b into a minus b is a square minus b square. So this is 1 square minus sin square a divided by cos A. Because a plus b into a minus b, a square minus b square. 1 square is 1. 1 minus sin square, which is cos square a. 1 minus sin square a is cos square a, because we know sin square a plus cos square a is 1. Sin square a plus cos square a is equal to 1. So we have cos square A is equal to 1 minus sin square A. Cos square A is equal to 1 minus sin square A. 1 minus sin square A is cos square A. Cos square A by cos A is equal to cos A. One cos will cancel, cos A. So answer is cos A. Option D is the answer. Solution is also shown here. Okay. Make a note of the solution. And also we're going to send the solutions also. The PDF format, we're going to send it in the groups. Okay. Move on to the next one. 1 plus tan square A. 1 plus tan square A divided by 1 plus cot square A. The simplified form is which one? To find out. 1 plus tan square A by 1 plus cot square A. So given expression is equal to 1 plus tan square A, 1 plus tan square A divided by 1 plus cot square A. We can write it as 1 by tan square A. Is equal to 1 plus tan square A divided by LCM take, I'll get tan square A plus 1 divided by tan square A. Like this. Taking LCM in the denominator tan square A. 1 plus tan square A and tan square A plus 1 are one and the same. This will cancel. This will cancel this. So what is left is 1 by tan square A. 1 by tan square A is equal to tan square A. Tan square A. That is option D is the answer. Solution is also shown here. Move on to the next one. Express the ratios cos A, tan A and secant A in terms of sin A. We should express cos A in terms of sin A. We have sin square A plus cos square A is 1, right? We have cos square A plus sin square A is equal to 1. From there we can write is equal to, this implies cos square A is 1 minus sin square A. Cos square A is 1 minus sin square A. So assuming that A is an acute angle, I'll write cos A is equal to root of 1 minus sin square A. Cos A is root of 1 minus sin square A. So we are expressing cos A in terms of sin. The first one is done. Taking positive square root, assuming that A is an acute angle. Acute angle means it lies in the first quadrant, that is 0 to 90. 0 less than A less than 90. Okay. 0 less than or equal to A less than 90. Tan A in terms of sin A. Tan is sin by cos. Now, tan A is sin A divided by cos A. Tan A is sin A divided by cos A. Correct? So sin A divided by cos A, we have root of 1 minus sin square A. Root of 1 minus sin square A. Correct? So tan A is sin A by root of 1 minus sin square A. That is tan A. Next one, secant A in terms of sin A. Secant A, if you want, I'll take reciprocal here. Secant A is 1 by cos A. Secant A is 1 by cos A. Already we have cos A as root of 1 minus sin square A. Correct? Cos A is root of 1 minus sin square A. So secant A is 1 by root of 1 minus sin square A. On to the next one. That is what we got. Correct? Sin A by root 1 minus sin square A. 1 by root of 1 minus sin square A. Move on to the next question. Prove that secant A into 1 minus sin A into secant A plus tan A equal to 1. Start from left hand side, get right hand side. Starting from left hand side, LHS equal to secant A keep as it is. 1 minus sin A also keep as it is. Here secant A write 1 by cos A. Tan A write sin by cos. So this is 1 by cos A. Tan A is sin A divided by cos A. Secant A into 1 minus sin A into, take common denominator, cos A. So what you get is 1 plus sin A. Inside this bracket is 1 plus sin A by cos A. Secant A is 1 by cos A. Tan is sin by cos. Taking common denominator, cos A, numerator will be 1 plus sin A. So this cos A, if you take it up, becomes secant A, because 1 by cos is secant A. Correct? This is secant A into 1 minus sin A into 1 plus sin A. A minus B into A plus B. A square minus B square. 1 square minus sin square A. This cos A will go up. 1 by cos A is secant A. Correct? Because 1 by cos A is secant A. Reciprocal of cos is secant A. Secant A into secant A becomes secant square A. The product of these two will be secant square A. 1 minus sin square A is cos square A. Correct? And secant square A is again 1 by cos square A. 1 by cos square A into cos square A. This cos square A is going to cancel, becomes 1 is equal to RHS. Hence proved. Starting from left hand side, we got right hand side. Secant A right as it is. 1 minus sin A keep as it is. This secant A is 1 by cos A. Tan A is sin A by cos A. Take common denominator, cos A. Numerator will be 1 plus sin A. 1 by cos A is secant A. Secant A into secant A is secant square A. 1 minus sin square A is cos square A. So secant square A is 1 by cos square A. 1 by cos square A into cos square A is 1. So LHS equal to RHS. Hence proved. Move on to the next one. Solution is also displayed here. PDF format will be sent. Next one, prove that cot A minus cos A by cot A plus cos A equal to cosec A minus 1 by cosec A plus 1. Start from LHS. LHS is equal to cot A minus cos A divided by cot A plus cos A. Cot is cos by sin. Cos A divided by sin A minus cos A divided by cot is cos A divided by sin A plus cos A. Here you take cos A as common in the numerator as well as denominator. If cos A is taken out, what remains is 1 by sin A minus 1. Denominator, cos A is common. So what remains is 1 by sin A plus 1. Cos A will cancel here. Cos A cancels. 1 by sin A is cosec A minus 1 divided by 1 by sin A is cosec A. So cosec A plus 1. Cosec A minus 1 by cosec A plus 1 is equal to RHS. Starting from LHS, we get RHS. This cos A is going to cancel. Cos A cancels. Hence proved. Starting from LHS, we get RHS. Please make a note of this. Move on to the next one. Solution is also displayed here. Question number 10. Prove that sin theta minus cos theta plus 1 by sin theta plus cos theta minus 1 equal to 1 by secant theta minus tan theta. Start from LHS. LHS equal to sin theta minus cos theta plus 1. Sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1. Sin theta plus cos theta minus 1. Because the right hand side is in terms of sec and tan, try to introduce secant and tan in the numerator as well as denominator. If you want secant and tan, you divide numerator and denominator by cos theta. So that sin by cos is tan and 1 by cos is sec and cos by cos is 1. Divide numerator and denominator by cos theta. Divide both numerator and denominator by cos theta. Divide numerator and denominator by cos theta. What we get? The left hand side is equal to divide numerator and denominator both sin theta by cos theta minus cos theta divided by cos theta plus 1 by cos theta. Divide by cos theta for numerator. Divide by cos theta for denominator. Sin theta by cos theta plus cos theta divided by cos theta minus 1 by cos theta. Sin theta by cos theta is tan theta. Cos by cos is 1. 1 by secant theta. 1 by cos theta is secant theta. 1 by cos is sec. Sin by cos is tan. Cos by cos is 1. 1 by cos is sec. Sin by cos tan. Cos by cos 1. 1 by cos is sec. So, and we know the identity 1 as secant square minus tan square. Correct? This is tan theta plus secant theta. Tan theta plus secant theta I wrote minus 1. Correct? Divided by tan theta minus secant theta plus 1. I'm writing one step extra to make you understand properly. Tan theta plus secant theta minus 1. Tan theta minus secant theta plus 1. Write 1 as secant square theta minus tan square theta. This is tan theta plus secant theta minus 1. You can write it as secant square theta minus tan square theta. 1 is a square minus 1 is secant square minus tan square, because 1 plus tan square is secant square, we know. 1 plus tan square theta is equal to secant square theta. From there we have 1 is equal to secant square theta minus tan square theta. You must know this. Rearrange the terms, we get like this. 1 is equal to secant square theta minus tan square theta. Denominator is tan theta minus secant theta plus 1. This takes the form a square minus b square, which is a plus b into a minus b. So this is tan theta plus secant theta. Tan theta plus secant theta. Put in one bracket. This is in one bracket. This I can factorize it. A square minus b square is a plus b into a minus b. This is secant theta plus tan theta into secant theta minus tan theta. Secant theta plus tan theta into secant theta minus tan theta. Divided by what we have is tan theta minus secant theta plus 1. Correct? So here tan theta plus secant theta is common from this. Tan theta plus secant theta if you take out, what remains? Right. So taking tan theta plus secant theta common from the numerator. Tan theta plus secant theta is out. What remains is 1 minus of secant theta minus tan theta. Divided by denominator is tan theta minus secant theta plus 1. Tan theta minus secant theta plus 1. So see, if you open this bracket here, 1 minus secant theta, minus into minus becomes plus tan theta. Correct? So 1 plus tan theta minus secant theta by 1 plus tan theta minus secant theta is going to cancel. Correct? So I can write here itself, remaining part. This is not required anyway for us. So remaining part I'm going to write here, this part. Therefore LHS is equal to what we got? Tan theta plus secant theta is same as secant theta plus tan theta. secant theta plus tan theta. This bracket if you open and write, it is 1 minus secant theta plus tan theta, correct? Minus secant theta plus tan theta divided by tan theta minus secant theta plus 1. Tan theta minus secant theta plus 1. This and this are exactly same. Tan theta is a plus tan theta. Minus secant theta minus secant theta plus 1. This entire thing will cancel. This entire thing is same as this, cancels. So what remains is secant theta plus tan theta. For this what we do is multiply and divide by secant theta minus tan theta. We'll rationalize. Multiply and divide by secant theta, not rationalizing, kind of just multiply and divide by secant theta minus tan theta. Numerator takes the form a plus b into a minus b, which is a square minus b square. So it becomes secant square theta minus tan square theta, which is 1. Correct? Numerator becomes 1. Numerator will be secant square theta minus tan square theta. And denominator is secant theta minus tan theta. Correct? Denominator is secant theta minus tan theta. Secant square minus tan square is 1. So I am getting 1 by secant theta minus tan theta. Hence proved is equal to RHS. Starting from LHS, I get RHS. Dividing numerator and denominator by cos theta, sin by cos tan, 1 by cos sec, correct? Then write this 1 as secant square minus tan square. Numerator 1 you write it as secant square minus tan square. Denominator 1 you don't change. So that numerator I get a square minus b square from this bracket. This is a plus b into a minus b. So that we can take tan theta plus secant theta common and go on simplify. After this step I wrote here these two steps, then I written here. Okay. So and I multiply and divide by secant theta minus tan theta finally to get the answer. So that's equal to RHS. The solution is also shown here. Please make a note of this. In detail I have shown the solution. Move on to the next one. Question number 11 we have. Prove that cosec theta minus cot theta the whole square is equal to 1 minus cos theta by 1 plus cos theta. Start from left hand side. LHS equal to cosec theta minus cot theta the whole square. Cosec theta minus cot theta the whole square. Cosec is 1 by sine. Cosec is 1 by sine and cot is cos by sine. Cosec is 1 by sine. Cot is cos by sine. Take LCM and simplify this. Common denominator is sine theta. This is 1 minus cos theta divided by sine theta the whole square. Correct? This is equal to 1 minus cos theta the whole square divided by sine square theta. Correct? Sine square theta I can write 1 minus cos square theta. Numerator a minus b whole square is a minus b into a minus b. 1 minus cos theta into 1 minus cos theta. Denominator sine square theta could be written as 1 minus cos square theta. Correct? 1 minus cos square theta takes the form a square minus b square. 1 is same as 1 square. A square minus b square is a plus b into a minus b. This is 1 minus cos theta into 1 minus cos theta divided by denominator is a square minus b square, which is a plus b into a minus b. 1 plus cos theta into 1 minus cos theta. 1 minus cos theta is going to cancel. What remains is 1 minus cos theta divided by 1 plus cos theta is equal to RHS. This will cancel. 1 minus cos theta will cancel. 1 minus cos theta by 1 plus cos theta is equal to RHS. Starting from LHS we get RHS. Hence proved. Please make a note of this. Move on to the next one. Question number 12 we have. Solution is also shown here. Question number 12. Prove that cos A by 1 plus sin A plus 1 plus sin A by cos A equal to 2 times secant A. Start from left hand side. LHS is equal to what we have? Cos A by 1 plus sin A. Cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A. 1 plus sin A divided by cos A. Taking common denominator here. 1 plus sin A into cos A. 1 plus sin A into cos A. Taking common denominator. 1 plus sin A into cos A. So this numerator becomes cos A into cos A, which is cos square A. Correct? Plus 1 plus sin A into 1 plus sin A is 1 plus sin A the whole square. This is equal to cos square A plus here A plus B whole square is A square plus B square plus 2AB. 2 into 1 into sin A, 2 sin A divided by 1 plus sin A into cos A. Expand this. A plus B whole square. A plus B whole square we know. A square plus B square plus 2AB. 1 square plus sin square A plus 2 sin A. And you know cos square A plus sin square A is 1. Correct? Cos square A plus sin square A is 1. This becomes 1 plus 1 plus 2 sin A divided by 1 plus sin A into cos A. So this becomes 1 plus 1. 1 plus 1 is 2. We get 2 plus 2 sin A divided by 1 plus sin A into cos A. Numerator 2 common. 2 is common. What you get is 1 plus sin A divided by 1 plus sin A into cos A. 1 plus sin A is going to cancel. What remains is 2 divided by cos A, which is 2 into 1 by cos A. 2 is 2 into 1, correct? So this is 2 into 1 by cos A is equal to secant A. So is equal to RHS. Hence proved. Take common denominator 1 plus sin A into cos A. Cos A into cos A, cos square A. 1 plus sin A into 1 plus sin A. 1 plus sin A the whole square. Expand this using the formula A plus B whole square. A square plus B square plus 2AB. Sin square A plus cos square A is 1. 1 plus 1 plus 2 sin A. 1 plus 1 is 2. So 2 plus 2 sin A. 2 is common. 1 plus sin A. 1 plus sin A cancels. 2 by cos A, which is 2 into 1 by cos A. 1 by cos A secant A. 2 into secant A is equal to RHS. Hence proved. Please make a note. And also solution is also shown here. And also the PDF format also will be sent along solutions. Okay. Questions with solutions will be sent in the group. Move on to the next one. Prove that tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta equal to 1 plus secant theta into cosecant theta. It's a quite important question. We'll start from LHS. Write tan as sin by cos, cot as cos by sin. Go on simplified, we'll get the answer. Starting from LHS. LHS equal to tan you write sin by cos. Tan theta you write sin theta divided by cos theta. Divided by 1 minus cot theta is cos theta divided by sin theta. Cot is cos by sin. Cos theta divided by sin theta. This is 1 minus tan theta is sin theta divided by cos theta. Tan you write sin by cos. Cot you write cos by sin. Take LCM in the denominator. This becomes sin theta divided by cos theta divided by sin theta minus cos theta, sin theta minus cos theta divided by sin theta plus cos theta divided by sin theta. Here LCM is cos theta, so I'll get cos theta minus sin theta divided by cos theta. Correct? A by B by C by D means it becomes AD by BC. Correct? You must know this. A by B divided by C by D means AD divided by BC. You must know this. A by B is divided by C by D means D goes and multiplied to A, B comes to denominator, gets multiplied to C, AD by BC. So sin theta goes up, cos theta comes down. Cos theta goes up, sin theta comes to denominator. A by B divided by C by D is AD. Dividing by a number means multiplied by its reciprocal in short, I can tell. So sin theta goes up, becomes sin square theta. This is sin square theta divided by sin theta goes up and multiplied to this sin theta into sin theta, sin square theta. Cos theta comes to denominator. This becomes cos theta into sin theta minus cos theta. This cos theta will go up. Cos theta into cos theta is cos square theta divided by sin theta into cos theta minus sin theta. Correct? Now, see denominators. Here it is sin theta minus cos theta. Here cos theta minus sin theta. We'll take negative sign outside from this. If you take minus sign out from this, this becomes sin minus cos. So left hand side becomes, write the remaining part here. For LHS equal to what we have? Sin square theta by cos theta into sin theta minus cos theta. Sin square theta divided by cos theta into sin theta minus cos theta. Correct? Here you take minus sign out. That minus will come out. Plus by minus becomes minus. If you take a minus sign out, cos minus sin becomes sin minus cos. That plus by minus will be minus. Okay. Cos square theta divided by sin theta into sin theta minus cos theta. So this is equal to, taking common denominator, here it is cos theta into sin theta minus cos theta. Taking common denominator, sin theta into cos theta into sin theta minus cos theta. This you have to multiply by what to get this? This term I should multiply by sin theta to get this. Correct? If we compare this and this, cos theta is there. Sin theta minus cos theta is there. That means you have to multiply this term by sin theta to get this. That sin theta into sin square theta becomes sin cube theta. Minus this and this, if we compare this term, I should multiply by cos theta to get this. That cos theta into cos square theta becomes cos cube theta. A cube minus B cube form. This is A cube minus B cube is A minus B into A square plus AB plus B square. Sin theta minus cos theta into sin square theta plus sin theta into cos theta plus cos square theta. Correct? A cube minus B cube. A minus B into A square plus AB plus B square divided by cos theta into sin theta into sin theta minus cos theta. Sin theta minus cos theta is going to cancel. Sin square plus cos square is 1, right? Sin square theta plus cos square theta is 1. This becomes 1 plus sin theta cos theta divided by cos theta into sin theta. Here you can separate the terms. Numerator is sum of two terms. A plus B by C means A by C plus B by C. Separate the terms, divide individually. So what you get is 1 by cos theta into sin theta plus sin theta cos theta into divided by sin theta cos theta. One is 1 into 1. So that 1 by cos theta is secant theta. 1 by sin theta is cosec theta. Plus sin theta cos theta cancels 1 is equal to RHS. Hence proof. Starting from LHS we get RHS. 1 plus secant theta cosecant theta. It's quite important question. It's quite important question. Please practice it, okay? Learn the formulas properly. Here I use a cube minus b cube formula. A minus b into a square plus ab plus b square. Where a is sin theta, b is cos theta. Tan is sin by cos, cot is cos by sin. Go on, simplify it and get the answer. Okay, this sin theta goes up. A by b divided by c by d. A by b divided by c by d means AD by BC. Remember this. AD by BC. D goes up, B comes down. That is what you use. And cos theta minus sin theta. From there I take a minus sign out. If you take minus sign out, it becomes sin minus cos. And plus by minus is minus. So that I can take the common denominator as cos theta into sin theta minus cos theta. So numerator will be a cube minus b cube form. A minus b into a square plus ab plus b square. Sin square plus cos square is 1. Sin theta minus cos theta is going to cancel. Sin square plus cos square is 1. 1 plus sin theta cos theta by sin theta cos theta. Separate the terms and divide individually, get the answer. Hence proved. Also we can do it by another method. You can write cot as 1 by tan and go on simplify, get the answer. Solution is shown here. I won't be doing that method also. This is the one method I've done already. Another method is also shown here. You can write cot as 1 by tan. Okay, go on simplify and express purely in terms of tan and do it. Okay, if you want to do that method also, that means I should add a page and do it. Okay, that means LH is equal to tan theta by 1 minus cot theta. Another method I am doing here. LH is equal to tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus tan theta. This is tan theta you keep as it is. Cot you write 1 by tan. Wherever there is cot you write 1 by tan. Plus cot you write 1 by tan. Divided by 1 minus tan theta. This tan theta will come to the denominator. Here you take LCM tan theta. After taking LCM, it goes to numerator. This is tan theta divided by, take LCM as tan theta. 1 is 1 by 1. So this becomes tan theta minus 1 divided by tan theta. This tan theta will go to numerator. Here this is 1 by tan theta into 1 minus tan theta. So this tan theta goes up. What we get is tan square theta divided by tan theta minus 1. Here what we do is take a minus sign out. 1 minus tan theta. If you take minus sign outside, it becomes tan theta minus 1. And plus by minus will be minus 1 by tan theta into tan theta minus 1. This is LCM will take tan theta into tan theta minus 1 is LCM. This is to multiply by tan theta. Look at this. Tan theta into tan square theta becomes tan cube theta. This is to multiply by 1 to get this. That 1 into 1 is 1. 1 is same as 1 cube. A cube minus b cube formula. A minus b into a square plus ab plus b square. You can factorize this. This is equal to tan theta minus 1. Tan theta minus 1 into tan square theta plus 1 plus tan theta, correct? Divided by tan theta into tan theta minus 1. Tan theta minus 1 is going to cancel. This is a cube minus b cube. A minus b into a square plus ab. Tan theta into 1 plus b square. Correct? Tan theta minus 1 cancels. And 1 plus tan square theta is secant square theta. Therefore, LHS becomes equal to tan theta minus 1 cancels. What remains is tan square theta plus 1 plus tan theta. Tan square theta plus 1 plus tan theta divided by what we have is tan theta. This is 1 plus tan square theta. I can write this as secant square theta. 1 plus tan square theta is secant square theta plus tan theta divided by tan theta. Now I can separate the terms. Divide individually. Secant square theta divided by tan theta plus tan theta divided by tan theta. Correct? Secant square is 1 by cos square theta. Tan theta is sin theta divided by cos theta. Tan theta cancels. 1 cos theta will cancel. So what is left is 1 by 1 cos theta will cancel. 1 cos theta remains. That comes to denominator. Becomes 1 by cos theta into sin theta plus 1. 1 is 1 into 1. This is 1 by cos theta is secant theta. 1 by sin theta is cosec theta. So 1 plus secant theta into cosecant theta is equal to RHS. Starting from LHS, we get RHS. Please make a note of this. There are two methods of doing this problem. Move on to the next one. Question number 14 we have. Prove that 1 plus secant A by secant A equal to sin square A by 1 minus cos A. Start from LHS. 1 plus secant A by secant A. LHS equal to 1 plus secant A divided by secant A. What again? This is 1 by secant A plus secant A divided by secant A. 1 by secant A is cos A. Separating the terms. Numerator is sum of two terms. Separate the terms. A plus B by C is A by C plus B by C. Secant A by secant A is 1. 1 plus cos A. For this, 1 cos A plus 1 is same as 1 plus cos A. For this, we'll multiply and divide by 1 minus cos A. Multiply and divide by 1 minus cos A. Multiply and divide by 1 minus cos A. So this becomes A plus B into A minus B is A square minus B square. 1 square minus cos square A divided by 1 minus cos A. 1 square is same as 1. 1 minus cos square A is sin square A. Sin square A divided by 1 minus cos A is equal to RHS. Starting from LHS, we get RHS. Secant is 1 by cos, separate the terms. 1 by secant A plus secant A by secant A. 1 by secant A is cos A. Secant A by secant A is 1. Cos A plus 1 is same as 1 plus cos A. Multiply and divide by 1 minus cos A and simplify like this. Get, starting from LHS, we get RHS. Hence proved. And also use 1 minus cos square A as sin square A. Fundamental trigonometric identity. Solution is also shown here. Move on to the next one. Question number 15 we have. Cos A minus sin A plus 1 by cos A plus sin A minus 1 equal to cosec A plus cot A. Because RHS is in terms of cosec A and cot A, I'll introduce cosec A and cot A. For that, we'll divide numerator and denominator by sin A. Cos by sin is cot, 1 by sin is cosec. So divide numerator and denominator by sin A. LHS equal to divide by sin A and write cos A divided by sin A minus sin A divided by sin A. Dividing by sin A for numerator and denominator each term. 1 by sin A. Here cos A divided by sin A. Cos A divided by sin A plus sin A divided by sin A minus 1 divided by sin A. So what do you get? Cos by sin is cot minus 1. 1 by sin A is cosec A. This is cot A plus 1 minus cosec A. Correct? Cos by sin is cot, 1 by sin is cosec. And what we'll do is, I'll write 1 as cosecant square A minus cot square A, because 1 plus cot square A is cosecant square A. From there we get this. Cot A I'll write first. Cot A plus cosec A I'll write as it is minus. This 1 could be written as cosecant square A minus cot square A. Cosecant square A minus cot square A. Denominator is cot A plus 1, cot A plus 1 minus cosecant A. Numerator takes the form here inside this bracket a square minus b square, which can be factorized as a plus b into a minus b. Cosec A plus cot A into cosec A minus cot A. This is cot A plus cosec A. Correct? This is cot A plus cosec A minus a square minus b square is a minus b into a plus b. Cosec A minus cot A into cosec A plus cot A. Divided by cot A plus 1, cot A plus 1 minus cosecant A. So we can take cot A plus cosec A common here. Correct? From this cot A plus cosec A is common. Cot A plus cosec A is common. So what remains is 1 minus of cosec A minus cot A. Taking cosec A plus cot A common from the numerator. Denominator is cot A plus 1 minus cosec A. Cot A plus cosec A same as cosec A plus cot A. This is cosec A plus cot A into, this is 1 minus cosec A, minus into minus plus cot A. 1 minus cosec A plus cot A divided by cot A plus 1, cot A plus 1 minus cosecant A. So cot A plus 1 minus cosec A is going to cancel. So what remains is cosec A plus cot A, which is equal to RHS. Starting from LHS, we get RHS. Cosec A plus cot A. Hence proved. Please make a note of this. On to the next one. Question number 16 we have. Prove that root of 1 plus sin A by 1 minus sin A equal to secant A plus tan A. Start from LHS. LHS equal to root of 1 plus sin A divided by 1 minus sin A. Here you multiply and divide by 1 plus sin A within the root. Multiply and divide by 1 plus sin A is equal to root of a plus b into a plus b. A plus b the whole square. 1 plus sin A into 1 plus sin A is 1 plus sin A the whole square. Here a minus b into a plus b is a square minus b square. 1 square minus sin square A. This is equal to root of 1 plus sin a the whole square divided by 1 square is 1, 1 minus sin square is cos square a using the fundamental trigonometric arithmetic. Correct? 1 plus 1, 1 plus sin a the whole square is the numerator. Denominator is 1 square 1. 1 minus sin square is cos square, because sin square a plus cos square a is 1. From there we get 1 minus sin square a equal to cos square a. So this could be written as root of 1 plus sin a by cos a the whole square. 1 plus sin a the whole square by cos a the whole square, which is 1 plus sin a by cos a the whole square. Correct? And square root of x square is actually mod x, but strictly speaking, that is for 10th standard level, we know that sin a and cos a are always positive because a is an acute angle. So 1 plus sin a by cos a is positive. Root of 1 plus sin a by cos a the whole square. Square root and square cancels. What we get is 1 plus sin a by cos a. Square root of 1 plus sin a by cos a the whole square. Square root and square root cancel. Square root means to the power half. Correct? Powers gets multiplied. 2 into half is 1. The power is 1. Means 1 plus sin a by cos a. This is 1 by cos a plus sin a by cos a. 1 by cos a plus sin a by cos a. 1 by cos a is secant a. And sin a by cos a is tan a. So I am getting tan a plus secant a, or secant a plus tan a is equal to RHS. Starting from LHS, we get RHS. Please make a note of this. Rationalizing within the square root, multiply and divide by 1 plus sin a, because denominator is 1 minus sin a. Multiply and divide by 1 plus sin a. 1 plus sin a into 1 plus sin a. 1 plus sin a the whole square. A minus b into a plus b square minus b square. 1 plus sin a the whole square. 1 minus sin square is cos square a, because sin square a plus cos square a is 1. So 1 minus sin square a is cos square a. So 1 plus sin a by cos a the whole square. Root of 1 plus sin a by cos a the whole square is 1 plus sin a by cos a. 1 by cos a secant a. Sin a by cos a tan a. Secant a plus tan a is equal to RHS. Move on to the next one. Solution is also shown here. Okay. Move on to the next one. Oh, I think one step is missing here, is equal to secant a plus tan a. I should write here one more step. That is 1 by cos a plus sin a by cos a. Last step is missing in this. Okay. I have written properly anyway. 1 by cos a is secant a and sin a by cos a is tan a. Secant a plus tan a is equal to RHS. Okay. I have written properly all the steps as required we got. Move on to the next one. Question number 17. Prove that sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta equal tan theta. Start from LHS. LHS equal to sin theta is common there. I'll write first what is LHS. Sin theta minus 2 sin cube theta divided by 2 cos cube theta, 2 cos cube theta minus cos theta. Here sin theta is common. Sin theta common. What remains is 1 minus 2 sin square theta. Denominator. Cos theta is common. What remains is 2 cos square theta minus 1. Sin theta by cos theta is tan theta. Correct? Into. Here 1 minus 2 into, right? Sin square theta is 1 minus cos square theta. Sin square theta is 1 minus cos square theta divided by 2 cos square theta minus 1. This is tan theta into, what you get is 1 minus 2 minus into minus is plus 2 cos square theta divided by 2 cos square theta minus 1. Correct? 1 minus 2 is minus 1. So numerator and denominator here it is same. Tan theta, this and this are same. Correct? This part is same as this part. So tan theta into 1 becomes tan theta into 2 cos square theta minus 1. 2 cos square theta minus 1 divided by 2 cos square theta minus 1. 2 cos square theta minus 1 cancels. What you get is tan theta is equal to RHS. Using sin square theta is 1 minus cos square theta. Open the bracket. 2 into 1, 2. Minus 2 into 1, minus 2. Minus into minus plus 2 cos square theta. 1 minus 2 is minus 1. 2 cos square theta minus 1. By 2 cos square theta minus 1. These two are same. Cancels out. What remains is tan theta equal to RHS. Hence proved. On to the next one. Question number 18 we have. Solution is shown here. Prove that sin A plus cosec A the whole square plus cos A plus sec A the whole square equal to 7 plus tan square A plus cot square A. Start from LHS. Just expand it using the formula A plus B whole square. A square plus B square plus 2AB. LHS is equal to sin A plus cosec A the whole square plus cos A plus secant A the whole square. Expand it. A plus B whole square, that is A square plus B square plus 2AB. Sin square A plus cosecant square A plus 2 sin A into cosec A. Expanding it. A plus B whole square. A square plus B square plus 2AB. Here also expand it. A plus B whole square formula. A square plus B square plus 2AB. Cos square A plus secant square A plus 2 into cos A into secant A. Correct? This is sin square A plus cos square A. Combine these two. Sin square A plus cos square A. Combine these two in one bracket. Sin square A plus cos square A. Cosecant square A is 1 plus cot square A. Right? Cosecant square A as 1 plus cot square A. 2 into sin A into cosec A is 1 by sin A. Secant square A is 1 plus tan square A plus 2 into cos A into secant A is 1 by cos A. So what do you get? Sin square A plus cos square A is 1 plus 1 plus cot square A. Here sin A is going to cancel, plus 2 into 1 is 2 plus 1 plus tan square A plus cos A is going to cancel, 2 into 1 2. Correct? This is 1 plus 1 2, 2 plus 2 4, 4 plus 1 5, 5 plus 2 7. So I am getting 7 plus cot square A plus tan square A. 7 plus tan square A plus cot square A is equal to RHS. Hence proved. Move on to the next one. Solution is also shown here in detail. Just expanding it using the formulas, and cosec is 1 by sin, sec is 1 by cos, and secant square A is 1 plus tan square A, cosecant square A is 1 plus cot square A. Using the identities, just go on through, get the answer. Next one we have question number 19. Cosec A minus sin A into secant A minus cos A equal to 1 by tan A plus cot A. Simplify LHS and RHS separately here. Simplify LHS first. LHS is equal to cosec A minus sin A, cosec A minus sin A into secant A minus cos A. Cosec A is 1 by sin A minus sin A. Secant is 1 by cos A minus cos A. Cosec is 1 by sin, sec is 1 by cos. So this becomes 1 minus sine square A divided by sine A. Take LCM, sine A, correct? Sine A is LCM. Sine A by 1. Sine A LCM. 1 minus sine square A by sine A. This is 1 minus cos square A divided by cos A. Take LCM, cos A. 1 minus cos square A by cos A. 1 minus sine square A is cos square A, correct? This becomes cos square A divided by sine A. 1 minus cos square A is sine square A divided by cos A. Correct? So 1 cos A will cancel here, 1 sin A will cancel. What remains is cos A into sin A. Cos A into sin A. This we call equation 1. LHS. Now I'll simplify RHS. RHS is 1 by tan A plus cot A. Tan you write sin by cos. Cot you write cos by sin. 1 by tan A, you can write sin A divided by cos A. Cot A is cos A divided by sin A. This is equal to 1 by, take common denominator, cos A into sin A. Sin A into sin A is sin square A plus cos A into cos A is cos square A. This sin A goes up, sin A cos A goes up, correct? Cos A sin A goes to numerator divided by sin square A plus cos square A, which is 1. Sin square A plus cos square A is 1. So this becomes cos A into sin A divided by 1. Sin square A plus cos square A 1, correct? That's equal to cos A into sin A. This is equation 2 we'll call. From 1 and 2, see LHS we got cos A into sin A. RHS also we got cos A into sin A. From 1 and 2, LHS equal to RHS, hence proved. Both will simplify to sin A into cos A only. LHS simplifies to sin A into cos A. RHS also simplifies to sin A into cos A. Thus LHS equal to RHS. From 1 and 2 we conclude LHS equal to RHS. From 1 and 2 we conclude LHS equal to RHS. On to the next one. Solution is displayed here. And this is the last question of this session. Exercise 8.3 is completely covered, okay, of chapter 8, exercise 8.3, trigonometry, introduction to trigonometry. I'll be doing all the videos connected to this 10th standard. So consider 1 plus tan square A by 1 plus cot square A first. Consider 1 plus tan square A divided by 1 plus cot square A. One plus tan square A divided by 1 plus cot square A. What we get? This is equal to 1 plus tan square A divided by 1 plus cot square A, right? 1 by tan square A. Take LCM there in the denominator. This is 1 plus tan square A divided by tan square A plus 1 divided by tan square A. Take common denominator, tan square A. Correct? LCM is tan square A. Tan square A plus 1 by tan square A. 1 plus tan square A is going to cancel. What you get is 1 by tan square A. 1 by tan square A is equal to tan square A. Correct? 1 plus tan square A cancels. 1 by tan square A is tan square A. Now consider 1 minus tan A by 1 minus cot A the whole square. 1 minus tan A divided by 1 minus cot A the whole square. One minus tan A divided by 1 minus cot A is 1 by tan A the whole square is equal to 1 minus tan A divided by here tan A minus 1 by tan A, tan A minus 1 by tan A, the whole square, taking common denominator here. Tan A is LCM, tan A minus 1 by tan A. This is equal to 1 minus tan A the whole square, 1 minus tan A the whole square divided by tan A minus 1 the whole square divided by tan square A. Correct? Square is there for everywhere. 1 minus tan A the whole square by tan A minus 1 the whole square by tan square A. 1 minus tan A the whole square is same as tan A minus 1 the whole square. You know that A minus B whole square is same as B minus A whole square. Correct? This will cancel. So what is left is 1 by tan square A, and 1 by tan square A is going to be equal to tan square A. This is equation 2 we call. This is equation 1 we call. So from 1 into LH is, 1 plus tan square A by 1 plus cot square A is tan square A. Even 1 minus tan A by 1 minus cot A the whole square is tan square A. Hence from 1 into all are equal. Hence proved. Solution is also shown here. With this, all the questions of exercise 8.3 along with solved examples of the class 10th textbook has been completely covered. Many more videos will be uploaded in the coming days. With this, I conclude. Thank you.